Section 5.4, the hyperbola. Definition of hyperbola is the locus of points in a plane such that the absolute value of the difference of their distances from two fixed points is a constant value. So notice the word difference of their distances and absolute value. Okay, so here we have an hyperbola. There's something called the transverse axes. You have two asymptotes. So remember, asymptotes are lines that the graph approaches but never crosses. We have a center, and we have two branches of it. We have focuses, vertices, and of course we start beautiful with the center in the middle, but we're going to move that center all over the place. Okay, here is your standard equations. Notice the negative sign. Remember, it's a difference that we're dealing with. A value is always under the biggest. If A is under Y, it's vertical. If A is under X, it's horizontal. Okay. Here, another couple distances we have here. The distance from the center up is called B. The distance from the vertices to the center is A, or the total distance would be 2A. The distance from the center to the focus is C. And there's a relationship such that C squared equals A squared plus B squared. Okay. So where that comes into play is to find the equation for the asymptotes. So we'll have one asymptote with a positive and one with a negative slope. The horizontal transverse axes, your slope is B over A, and if it's a vertical transverse axis, we're going to have A over B. And then what we do is we just take the one line will have B over A, and the other one will be negative B over A, and likewise here, we would have A over B and negative A over B. Okay, so just if it's horizontal or vertical. So remember, we figure that out by this. Come on, page. There we go. It's horizontal if the bigger number is under X, and it is, or sorry, not even the bigger number, if the positive number, that's what it is, because this is going to be minus something. So the positive one is X, it's horizontal, and if the positive one is Y, because we have that minus sign there, then it is vertical. That's what it is. Okay, ready? We're going to determine all the features of this hyperbola right here. 4y squared minus x squared minus 16 is equal to 0. So the first thing I'm going to do is I'm going to get it into a form that I like. Okay, so I'm going to first of all go 4y squared minus x squared is equal to 16. Then I am going to divide everything by 16 because this is the form that I want it to look in, because this tells me some information here. So I want it to equal 1. Okay. So in this case, if I divide everything by 16, I now get y squared over 4 minus x squared over 16 is equal to 1. Okay, notice that my y squared is positive. I'm subtracting the x squared. So that tells me right away that the transverse axis is vertical. Okay, so I'm going to make a note. It's a vertical. What was the transverse axis again? That means that it's this way. So this is horizontal. I said I have what? Vertical. Okay, so I have my hyperbole looks like this, because there's my transverse axis in there. Okay, a couple things to look at. My center is H and K, so it's still HK. We'll make that note, and it's going to be 0, 0, because I don't have y minus something squared or x minus something squared. My vertices are going to be 0. My x value is going to be 0. My vertices are going to be, remember, they're going to be like here and where are my vertices? Vertices, yeah, are going to be there and there on my hyperbola. So they're going to be here and here. So my x value is going to remain 0, and my y value is going to change. And it's going to change so that its length is a. And remember, let's just do this right now. From this equation, I could tell you that a is equal to, a is going to be, a squared is 4, so a is 2. B is going to be 4 because its square root is 16. And c squared is equal to a squared plus b squared. So that means c squared is equal to 4 plus 16. C is equal to the square root of 20, which is 2 root 5. Okay? So my vertices, the length between here, the center, and a vertice is going to be a. So I'm going to add a and subtract a from my center, from this. Okay, my focuses are also going to be here along that same line. So this is going to stay the same. So I'm going to put 0 plus or minus a there as a note. So they are going to be c away from each other. So 0 plus 2 root 5 and 0 minus 2 root 5. Okay, so I'll write that in there. B. C. I'm saying the wrong thing. I'm going to circle that. Okay. My transverse axes, so this length is going to be a plus another a. That total length is going to be 2a. The equation of my asymptotes, okay? So what I need is, remember it was y equals mx plus b. B in this case is not this b. No, it means y-intercept, okay? So, so my m is going to be plus or minus a over b because of the type. If I forgot that, if I forgot the type, I believe I just look right here because it was a vertical, a over b. Okay, so I have a over b plus b. B is actually my y-intercept. So if you look at the asymptotes, you'll notice that they always go through the center. So that's going to give me my y-intercept. It will be my y-coordinate of my center, which is 0. Okay, so it's just too bad that they use the same b there. So y equals plus or minus a, remember we said was 2, b was 4, plus 0, x plus 4. So y is equal to plus or minus 1/2 of x. Those are the lines. Those are the equations of the equation of asymptotes, rather.